Hey everyone, this is Parabola Day 1 Notes, and of course you can get the worksheet if you don't have it already on the video calendar of our website. Okay, so getting started, we have the set definition and conic definition of a parabola. So the set definition is a parabola is a set of all points x and y that are equidistant from a fixed line, the directrix, and a fixed point, the focus, which will not be on the line. Conic definition is a parabola is an open curve formed by the intersection of a double napped cone in a plane that is not parallel or perpendicular to the axis of the cone. So make sure that you know both of those definitions. And let's go ahead and look at these two pictures. We've got a horizontal and a vertical parabola. We've studied parabolas before, but not quite in this way. And also we didn't use the horizontal parabolas because of course that would not be a function, as if you drag if you drag a vertical line across the parabola left to right or right to left, that vertical line would hit more than one point after you get past the vertex. So this horizontal parabola is not a function. Okay, but these two pictures, it doesn't matter if it opens to the left or to the right, up or down, the way we label it will always be the same thing. So the axis of symmetry will go through the vertex. If you've got this curve of the parabola here, it will always go through the vertex and divide it in half, which makes sense because it is an axis of symmetry. And then this other line, the directrix, that's going to be perpendicular to the axis of symmetry, and will always be p units away from the vertex. Also, on the other side of the vertex, p units away will be the focus. And so we've had foci in the ellipses and the hyperbola, so we'll just have one focus for a parabola. So the vertex is right in the middle of the directrix and the focus. So say you knew those, you could use the midpoint formula. This dashed line here, we don't draw that usually. It actually is not just half of it. This whole thing here, that is all of that is called the focal segment. And the focus is right in the middle of it. Over here on the right-hand side, you can see the same thing. This is a vertical one that happens to be opening down. And so again, we have the vertex, axis of symmetry going through it, directrix perpendicular to the axis of symmetry, p units away from the vertex. On the other side of the vertex, p units away is the focus, through which goes the focal segment, and we'll connect these 2 points here on the outside of the parabola. So we have the standard graphing form of the equation of a parabola. We've got the horizontal and the vertical to match the pictures up here. So the vertex will be at HK. So that's just the same as we've done for all of the conic sections. H will be the x value, and then K will be the y value. So you keep it with the x and the y. For a horizontal parabola, the non-squared term is going to tell us what's horizontal. So since the x is not squared, this is going to be a horizontal parabola. So then the y is squared. And then we'll have that 4 times p. Again, that's the distance from the directrix to the vertex and the vertex to the focus. So we'll have 4 times p. For vertical, the thing that is not squared is the y. So this is going to be a vertical parabola. So we'll have x minus h squared equals 4p times y minus k. So you'll notice the only things that switched were the parentheses, the y minus k or the x minus h. So the non-squared term is going to be what will help us figure out which direction it is opening. So we'll open right when 4p is greater than 0 for a horizontal, and we'll open left when 4p is less than 0. For vertical, it will open up when 4p is greater than 0 and down when 4p is less than 0. And then on the bottom half of the notes, you'll see all of these definitions that put into words the labels on the picture. A parabola only has one squared term. When the y term is squared, it will open left or right, making it horizontal, and it is not a function, as we've already mentioned. When the x term is squared, the parabola will open up or down, making it a vertical parabola that is a function. So vertical parabolas are functions and horizontal parabolas are not. Again, p is the distance from the vertex to the focus, which is also the distance from the vertex to the directrix. And then we've got the focus of the parabola, the axis of symmetry, directrix, focal segment, and the endpoints of the focal segment All of these are labeled in the picture. The only one we haven't discussed so far is this endpoints of the focal segment, which were the points on the arms of the parabola. So the endpoints of the focal segment are 2p, the absolute value, units away from the focus. So they are counted up and down from the focus if it's horizontal, and left and right from the focus in a vertical parabola. So just so that we are extra clear on that, half of the focal segment is 2p. So either one. So then all the way across, that is 4p. And that's true for the horizontal or the vertical. Okay, so let's check out these two examples. So on this first one, we have x minus 2 squared equals 8 times y plus 1. Okay, so the vertex, we just look at the x and the y, and we take the opposite signs. So we'll have 2, negative 1. Okay, the non-squared term is the y, so that means it's going to be vertical, which means we only have two options, up or down, that it will open. So then what we have to do is look at this 4p term of 8 and think, is that greater than or less than 0? Well, it's greater than 0, so that means it will be opening up. Okay, and again, that 8 is what is 4p. So 4p equals 8, so then p would equal, divide both sides by 4, and you get 2. And then the length of the focal segment, remember that is 2 times p, so 2 times 2, we get 4. So let's start graphing this. We have a vertex at 2, negative 1. We know that it opens up, and we know that the value for p is 2. So 2 out in each direction will tell us where the directrix and the focus are. So because it opens up, that's the direction of the focus. So we'll go up 2, there's the focus. If we go down 2, that's going to be where the directrix is. And it'll just be a dashed line better than what I'm drawing here. So there's our directrix. And then the length of the focal segment is 4, so that means all the way across going through the focus right here would be rewind here. It is not 2p that is the length of the focal segment, it's 4p. I was thinking about how to get to the endpoints. So 4 times 2, that'll be 8. Okay. So all the way across going through the focus will be a length of 8. So going out 4 on each side will bring us to the endpoints of the focal segment. So I'll go out 1, 2, 3, 4, and out 4 the other direction, 1, 2, 3, 4. So all the way across is 8, which is going to be that 4p, but to each point is the 2p. These are the points that we'll connect our vertex to. And there's our parabola. So the focus was at 2, 1. The equation for the axis of symmetry, that's perpendicular to the directrix. It goes through the vertex and the focus, and that is the line x equals 2. And then the equation of the directrix, that horizontal dashed line right here. Gracious, I'm just making all sorts of mistakes, aren't I? So let's see, there's supposed to be the directrix. I counted too far. It should only be 2 units away, the value of p. So this was the value of p away, so is this. All the way across was 4p, each side is 2p. Guess recording on a Saturday? My brain's not quite there. All right. So we have the equation is 1, 2, negative 3. So we have y equals negative 3. Okay, so let's try this next one, and hopefully I won't make those same silly mistakes. All right. So the vertex here, we take the opposite signs for the x and the y, so we have negative 2 and positive 3. Okay, so for the direction, we see the non-squared term is the x. That means it's going to be horizontal. Then to figure out if it's opening left or right, we look at that 4p term. So here the 4p is the negative 4. Well, that's less than 0, so that means it's going to be opening to the left. So 4p is negative 4. So then p, if you divide both sides by 4, you'll get negative 1. The length of the focal segment is 4 times p, or just that number we have sitting there, which is negative 4. But because it is just the length, we don't have to worry about its negative. If you'll remember in the definitions, it's the absolute values, so then it's positive 4. So just the length. We don't include the sign. Now there are some teachers who may include the sign, but as far as our concerns, or maybe even in your book, you may see that. I'm not too sure. I can't remember. But as for our purposes, it'll be the absolute value, so then the length would be positive 4. Okay, so the vertex is at negative 2, 1, 2, 3. We know it opens to the left, so then to find the focus, we'll take the value of p here, and we'll go ahead and say that p is a distance of 1 if you wanted to think about it, the absolute value. That negative just tells us we're going towards the left here, so you could think about that as positive 1 as well. We're not worrying about the signs for p and 4p. Okay, so we're going to the left 1 for the focus. So that's the point 1, 2, 3. Negative 3, 1, 2, 3, positive 3. So negative 3, positive 3. The directrix will be the same distance going the other direction from the focus. So that will be this vertical line right here. So that's x equals negative 1. The equation for the axis of symmetry is that line perpendicular to that. So that will be the equation y equals 3. And then the length of the focal segment is 4, so then we need to go out 2 on each side. So you can see here it's a total of 4 all the way across. And then those are the points that we'll connect our vertex to. And there we go. Okay, so there's 2 more things on this paper. That is aside from the homework problems on the bottom. But I would like for you to practice writing the equations for these 2 parabolas right here. And then we'll go over them in class. Okay, well hopefully I haven't confused you too much. Just be sure to refer back to the notes. And I will see you in class. And I hope you're having a great day. Bye.